Good morning, students. In last lecture we saw the mechanism behind the electrochemical cell, and also we saw the what is the meaning of electrode potential, single electrode potential, then what is the meaning of cell potential, that we saw in yesterday's last lecture. Today we will start with the very interesting topic, a very interesting point, thermodynamics of electrode potential. Thermodynamics of electrode potential. Nernst equation. It's very important point, exam point of view. Very important. So many questions have asked on this point. So we'll start with Nernst equation. So if you want to derive this equation, you have to take the help of Van 't Hoff isotherm. If you want to derive the Nernst equation, you have to take the use of this Van 't Hoff isotherm. Next, consider a chemical reaction. Consider a chemical reaction. AA plus BB Q CC plus DD. These are nothing but reactants, and these are nothing but products, isn't it? Now, electrical work done is by thermodynamics point of view. Electrical work done is nothing but the Gibbs free energy change. Very important. According to thermodynamics point of view, electrical work is nothing but the Gibbs free energy change. Gibbs free energy change at constant temperature and pressure. Scientists considered electrical work done is nothing but the delta G, Gibbs free energy change. The decrease in Gibbs free energy change. Why this negative sign? Decrease in Gibbs free energy change. For decrease, they have put down the sign negative here. Now, we will see decrease in free energy change. Decrease in free energy change due to above chemical reaction. Due to above chemical reaction is given by, or is given. Okay. How can we write? Now I'll write it here. Delta G minus delta Z0 minus RT ln activity of product divided by activity of product. Very important. Decrease in free energy change due to above chemical reaction is given by, minus stands for decrease, delta G is equal to minus delta Z0 minus RT ln activity of product divided by activity of reactant, where delta G0 is nothing but standard free energy change. Standard free energy change. Then R stands for gas constant. Then T is nothing but absolute temperature. Are you getting what I am saying? Where delta G0 is nothing but standard free energy change. R is nothing but gas constant. And T is nothing but absolute temperature. Now we can, now I'll write it here. there is no space. Now we can put down the values of product and reactant in above equation. Consider this equation is equation number 1. Equation number 1. Minus delta Z Z0 minus RT ln activity of C into activity of T D divided by activity of A small a, activity of B small b. You can also write it down by this way, by putting the values of product and reactant over here. Suppose, or if E0 is standard EMF of the cell, then it is given by E0, then it is given by delta Z0 is equal to ME0F. If E0 is standard EMF of the cell, then the standard free energy change is given by, you can also write it down here, standard, because we have considered standard EMF of the cell, that's why we have to consider standard gives free energy change. Very important, free energy change. Free energy change is given by this equation. Similarly, we can write down for gives free energy change. Similarly, delta G minus delta G decrease in free energy change is given by NE. This is nothing but the electrical work done by the cell. We have considered electrical work done of cell is nothing but the decrease in free energy change. That's why on that point of view, or from that thermodynamic point of view, we can write down these two equations. One is for standard, one is for normal. Now put down these values of delta G and delta G0 in equation 1, or in this equation. We consider this equation as equation 2. Now put down these values of delta G and delta G0 in equation 2. I'll write it here. Put the values of delta G and delta G0 in equation 2. In equation 2. What are the values? NEF and E0F. This is nothing but the equation 3. very important. समझ में आ रहा है? बहुत सिंपल है. इलेक्ट्रिकल वर्क डन को गिब्स फ्री एनर्जी चेंज कंसिडर किया है, ये बस ध्यान में रखो. So this is our equation 3. Moving forward, dividing this equation by NF, or divide equation 3 by dividing equation 3 by NF. Dividing equation 3 by NF. This is right. तो इस इक्वेशन को NF से डिवाइड करो, what you will get after dividing? E is equal to E0. NF get cancelled. Here again NF get cancelled. Minus RT divided by NF ln activity of product activity of reactant. We can also write down by this way. आप इक्वेशन 1 में भी पुट डाउन किया तो भी चलेगा, इक्वेशन 2 में भी पुट डाउन किया तो भी चलेगा. दिस इज द जनरल इक्वेशन. नाउ log to the base e, convert it to log to the base 10. What we will get? We will get 2.303 RT NF log to the base 10 activity of product divided by activity of reactant, where this is our Nernst equation, thermodynamics of electrode potential. What is the meaning of N? Where N is number of electrons. This is the Nernst equation for cell potential. You can call it as equation 4. This is Nernst equation for cell potential. For cell potential, very important. What is N? Number of electrons. We can also write down this equation in one more form. E is equal to E0 minus 0.0591 divided by N log to the base 10 activity of product divided by activity of reactant. Very simple. Where 2.303 RT upon F is nothing but 0.0591. F is nothing but Faraday's constant. F is nothing but Faraday's constant. E is nothing but EMF of the cell. What is it? This stands for is EMF of the cell. This is standard EMF of the cell. N is number of electrons. F is Faraday's constant. R is gas constant. T is the absolute temperature. Activity of product and divided by activity of reactant. So this is one of the form of Nernst equation. You can call it as equation 5. So this is the Nernst equation for cell potential. Now we will write Nernst equation for electrode potential. How can we write down the Nernst equation for electrode potential? So consider a metal, or when a metal is dipped in the solution containing its own ion. When the metal dipped in the solution containing its own ion, it is given by this reaction will happen over there. When metal is dipped in the solution containing its own ions. Now potential of this electrode is given by E is equal to E0 minus 2.303 RT NF log to the base 10 activity of metal divided by activity of Mn plus. This is the Nernst equation for above electrode. Now keep one thing in your mind, that activity of pure metal is always 1. Activity of pure metal is always 1. Keep this thing in your mind. Very important exam point of view, objective question point of view. Activity of pure metal is always 1. So it will becomes 1. What is N is nothing but number of electrons. So E is equal to E0 minus 2.303 RT NF log to the base 10 1 upon activity of Mn plus. We can rearrange this equation to this form. This is the final equation, Nernst equation for electrode potential. We have rearranged this equation to this form. So this is nothing but Nernst equation for electrode potential. very important term. होल टॉपिक में ये इक्वेशन यूज होने वाला है. टाइप्स ऑफ इलेक्ट्रोड्स, और यू कैन से इन लिक्विड जंक्शन पोटेंशियल, देन केमिकल सेल विदाउट ट्रांसफरेंस, विद ट्रांसफरेंस, कॉन्सेंट्रेशन सेल विद ट्रांसफरेंस, विदाउट. हर जगह पे ये इक्वेशन यूज होने वाला है, नर्स्ट इक्वेशन. So this is about thermodynamics of electrode potential or the Nernst equation. In next lecture we will see the types of electrodes, how many types of electrodes are there, and we will see the potential of that electrodes. Thank you very much.